Hello, in this very short video we discuss integration of even and odd functions. Firstly, let's remark about even and odd functions. A function f is called an even if f of negative x equal to f of x. And a function is odd if f negative x is equal to negative fx. Of course, in this case we consider, the domain of such functions are symmetric with respect to the origin. Okay, let's mention that domains is symmetric with respect to the origin 0. So that means you might have like negative a, or close interval negative a and a, something like that, for a greater than or equal to 0, greater than 0. All right. So if you remember, the graph of even functions are symmetric with respect to the y-axis. Why? Because you pick a x and negative x, right? You have the same y level. So if you graph the function, so the graph of, let's say, of even function is symmetric with respect to the x-axis. So this gives us some idea when we integrate the function, okay, to the y-axis. Okay, so and then if you want to integrate the function, okay, let's say from negative a to a, right? From negative a to a. So you can see that actually in this case you have the area of region enclosed by the graph of the function and straight line x equal to negative a and x equal to a and x-axis. So it's obvious that these two areas have the same, these two regions have the same area. Is that correct? So it should say, yeah, the same area. So that's why when you evaluate integral from negative a to a of such a function, that's just double of integral from 0 to a f of x dx if f is an even function on negative a to a. Does that make sense? So if you consider an odd function, from the definition of an odd function, we know that the graph of an odd function is symmetric with respect to the origin. Why? Because when you change from x to negative x, you have negative y. You see that? So you have the following picture. X or y. Okay, you have x or y in here. Then you might have the following, like, just very simple example. Okay, so you consider the function from negative a to a. Okay, and since this is an odd, the graph is symmetric with respect to the origin. Okay, because if you have an x and y in here, you have some points, x, y in here, and when you interchange to negative x, right, you have negative y. So that means you should have negative x and negative y in here. Does that make sense? And both points belongs to the graph function. So they are symmetric with respect to the origin because of f of negative x equal to negative f of x. Does that make sense? So when you integrate an odd function on negative a to a on some symmetric interval, you would get just 0. Okay, so now this very simple observation sometimes helps us to shorten the solution and save a lot of time. Okay, but before we move to an example, let me give you typical examples of even function, right? That is x squared, and odd function is x cubed. Okay, now let's consider the following integral. Let's evaluate the integral from -1 to 1 of x to the 4 plus x squared plus 3 dx. So, our function is uneven. Function f of x equal to x to the 4 plus x squared plus 3 is even. Why? Because you consider f of negative x, right? You get negative x to the 4 plus negative x squared plus 3. So that is just x4 plus x squared plus 3. That's f of x. And the interval -1, 1 is symmetric. So our integral is just equal to 2 times integral from 0 to 1 x to the 4 plus x squared plus 3 dx, right? And let's find antiderivative of this. That is 2 times x to the 5th over 5 plus x cubed over 3 plus 3x. This is evaluated from 0 to 1. The function at 0 is 0. We don't write it. At 1, I have 1/5 plus 1/3 plus 3. And to simplify this, we're 2 times over 15. 3 plus 5 plus 3 times 15, which is 45, 50, 53. So I have 106 over 50. That is the final answer. Does that make sense? So otherwise you of course you can evaluate from -1 to 1, right? But sometimes that saves your time. Let's consider another example. If I change the function a little bit, alright, let's evaluate integral from -1 to 1. Let's pick this function, 2x to the 5th plus 3 x cubed minus 7x dx. Okay, so yeah, you can write the answer right away. That is 0. Why? Because the function f of x equal to 2x fifths plus 3x cubed minus 7x is an odd. Is an odd. Because f of -x equal to 2 negative x to the 5th plus 3 negative x cubed minus 7 negative x. So you get, -2 x to the 5th minus 3 x cubed plus 7x. And this is nothing but, negative f of x. And we know that, we integrate on the symmetric interval, you get 0. Because they will be cancelled out. Right? They will be cancelled out right here. Because, for this guy, you have a negative area, and this guy, you have positive area. And they should have the same absolute value, right? But with different size. So when you integrate that, you get 0. Does that make sense? I think I need to write this right away from -a to 0, f of x dx, and then plus 0 to a, f of x dx. So when you change, the variable, you will get, negative of this right away. They will cancel out. Okay, so of course you might do changing variable, right? You might do substitution, but from this picture you see, yeah, one part is just negative area, another one is positive area. So when you integrate it, they will be cancelled out because they have the same absolute value. Does that make sense? All right, let's consider one more example and then we finish this video. Let's talk about trig function. Let's evaluate integral from negative pi over 2 to pi over 2 psi cube x cos x plus psi x cos x dx. Before we solve this integral, I would like to mention one thing. The function y equal to psi of x is an odd. Why? Because psi of negative x is equal to negative psi of x. Okay? And the function y equal to cosine is an even. Because we know cosine of negative x is equal to cosine of x. You can see all this on the unit circle. Right? This is your unit circle. This is the cosine a6 and this is the sine a6. So suppose that you have an x in here, right? That is your x. So what is negative x? Negative x is right here in a negative direction. So in order to find the sine, you need to draw a horizontal line, right? This is sine of x. And what is this? That is sine of negative x. And you see, these two guys are symmetric with respect to the origin. So that's why psi of x is equal to negative psi of x. Does that make sense? You do almost the same thing for cosine. But look at this. You have x in here. You have negative x right here. What is cosine? Cosine is right here. You draw a vertical line, you get cosine. So you see, cosine of x and cosine of negative x share the same position, right? So it means they are equal. So the cosine is an even and the sine is an odd. Okay? And as we have seen, the x cubed is also an odd function. Okay? And now look at this. So we might think about this function. Of course, you can solve this, using substitution. It's not a big deal. But I see the interval of integration is negative pi over 2 to pi over 2. Right? That is symmetric. And we work with, odd and even functions, sine, cosine. So you might think, yes, we may, save sometimes from that. Now, let's see. Sine cube is an odd function times cosine is an even. So this function is an odd. We will show that right now. It's just an observation. This is an even, this is an odd. So the product of an even and odd is an odd. You see, you have sum of two odd functions. So this function, the integrand function, is an odd. That means this integral is just equal to 0. Okay, so let's show that. Let's show that the function integrand function is an odd. The integrand function is odd. Okay, so our function is f of x equal to psi cube x cosine x plus psi x cosine x. We need to consider f to negative x. You get psi cube of negative x in here, cosine of negative x. So you replace x with the negative x everywhere, right? Cosine of negative x. And from this observation, we have negative psi x cubed times cosine x plus negative psi x times cosine x, right? So from here, we have negative psi cube x cosine x minus psi x cosine x. And if you take negative before all the expression, you get psi x cosine x minus psi x in here, cosine x. And this is nothing but, f of x, right? So f of negative x is equal to negative f of x. The function is odd. Okay, so the integral is 0. You see, it looks very interesting, right? Very simple. And from this example, as I mentioned, right, when we discuss about the integrand function, we see the product of an odd and an even is odd, right? Don't forget that. Product of an odd and an even is odd. Okay, so that's how we can use this statement in this integral. So I think I finished my video in here, and it's pretty small and pretty easy. But again, right, sometimes if we can recognize the function, the integrand function, that saves a lot of time. Okay, so see you in the next video. Bye.